All right, so it's 9 o'clock, and I guess we'll go ahead and start here. We're building ourselves a Glitchworks R6501Q single board computer kit today. This was laid out for Vintage Computer Festival East. We were supposed to be doing this back in April, and then of course coronavirus happened. So the overarching theme for Vintage Computer Festival East this year is 6502 related. Rather than do just another 6502 single board, since there's plenty of those out there and a lot of them are really popular and really nice, we decided we were going to use the Rockwell R6501Q. The R6501Q is mostly 6502 like, but it has a few things about it that are different. The main thing that really throws 6502 code off is that 0 page contains registers for the I/O devices, the internal processor registers, and also contains the stack. So instead of being on page 1, stack is down in page 0, and page 0 is all internal RAM, and there's only 192 bytes of it. So modifying software for it's a little bit of work. We ported the WAS monitor over to it. That was mostly Tangent Delta's efforts there, and we're pretty sure we have Tiny Basic fully ported. We'll make that available a little bit later on. And we're working on Enhanced Basic as well, but that's a much bigger project. So the data sheet for the R6501 is available online in PDF form. Gives you your package specifics here, interface requirements, some internal structure. If you go back through here, you can go through your processor registers. A lot of this is the same thing as the 6502, just rehashed here. And then, of course, you got your internal your port configurations, which if you're going to do any interfacing on this, you're going to want to dig through this and understand it. It's a little different than like talking through an 85 or 6522 rather. But yeah, so got all your timing diagrams and stuff on there. We'll go ahead and take a look at the kit. So if you have ordered a kit already and you're following along at home, you should have approximately what you see here in front of us. You've got the IC foam kit, you've got the main processor in a little box here to keep it from getting crushed. You've got your medium-sized parts kit and your small parts kit in the envelope. There's no real trick to assembling these things. I typically start with the shortest components and then work my way up to the tallest components, just because I figure most people are going to assemble these things without the aid of a assembly vise, like a pan of ice or something. So we'll go ahead and get started with the small parts kit. And these are, oh, hey, this one's missing the capacitors. All right, thank you.
Mm-hmm.
So your capacitors probably came on a strip like this. They may not be exactly this color. In later kits, all the ones that shipped before the show should look like this. Just grab them and pull the two pieces of paper away from each other to separate them, and then pull all the caps off. If you have a 1/8 watt resistor lead form, you can use position 2 to bend these. This is a lead form. If you do much assembly, they're definitely worth having. You can also 3D print them, but you just place it in the number 2 slot, put your thumb over it, and then bend the legs down. And we're going to go ahead and do that for all 10 of these. And you don't have to use a lead form. You can do this by hand. The lead form makes it a little easier and neater. Of course, we have lead forms because when you're doing 20 kits or something, your fingers would be bloody by the end of doing all those caps. Especially on something like the OSI boards where you got 30 caps on a board or something. Alrighty, and to stuff them in, you just they go. The yellow caps go in all the little areas labeled with just a C instead of a value, and you just put them in. And then on the back side, you bend them out a little bit there, so they stay put. And there's no polarity on these; they can go in either way. For those of you who've built kits before, this entire thing is probably going to take about an hour. If you haven't built a kit before, but you know how to solder, plan on, I don't know, maybe 2 hours. we have one more capacitor than just double check here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, one more. Alright, so then I go ahead and solder them. Today we're going to be using Kester organic core solder here. I do not recommend that you use this if you're just a hobbyist who's not planning on washing your boards. It must be washed. If you're not going to wash, then just use your regular 44 core or some other quality rosin core solder. But run the iron at 750 here. 650 is also fine, or whatever you're comfortable at. Alrighty, and once you got them soldered down, you're just going to clip the leads off. There's nothing that you need to save them for on this board, so you can set them aside, throw them out, whatever you do with your clipped off leads there. Alright, now we're going from shortest component to tallest component, so resistors are next. All of the axial resistors in this kit are the same. They're 4.7 Ks, and if you have a quarter watt lead for them, you're going to use position 1. Now there's other resistors we won't be installing on this kit because we're shipping R65X1Qs. If you're building this with your own parts and you have a R6511Q, then you need to add those other 4 resistors. And that's covered in the manual. It's also mentioned right here on the silk screen. So we're going to avoid installing R1, R2, R3, and R6. And all of those are done as hairpin resistors. So that they are distinctly different, to sort of make that obvious for which ones you need to install, which ones you don't. And they're, again, no polarity, so you can put them in either way. 2 down, 1 up here. So there should be 4 of these total if you're using an R65X1Q. There will be 8 total if you're using an R6511Q. Flip it over and solder. And clip the leads off. Alrighty, now the next thing to do is go ahead and stuff the non-socketed ICs. So that's all of your 20-pin dips and your 14-pin dips. You want to save the max 232 for later because that does get socketed, so don't solder it in at this point. And obviously don't solder any of the big chips at the moment. We save those for later. So you have 3 LS245s, HCT 688, an 04, 10, and a 20. It doesn't matter which order you put them in. Just thing to do, I think, is put them all in and solder the corners, and then double check and make sure you got everything in the right place before you go and solder all the pins. These have some spring in them where they've just come out of IC tubes, so you may find it easier to sort of flip the thing over and roll the pins a little bit on the desk. You can also leave the spring in them and just push it in with your thumbnail and get them into the hole. If you leave the spring in them, they stay in the holes in the board without solder, so you can flip it over and get to it that way. Okay. 20. 4. Oops. Put the pin out there. That's something you got to be careful of. You don't bend your pins out and have them either go off to the side or under the IC. If they go under the IC, they're a little harder to find. This one has too much spring in it, and you see it's popping out of the board there. So just flip that over and just tab out one of the legs there to make it stay. And then the 74 LS10. So once you got everything in, flip it over. I typically solder pin 1 and then whatever the opposite corner is. So put a little solder on pin 1, then press down and reheat it so that you're nice and square with the board. And you're just going to go through and tack all the ones that you have installed. Alright, once you have all the corner pins installed, flip it back over and inspect. Make sure your ICs are down tight on the board, and make sure that all of the parts are in their correct locations. There's a PDF manual that has a assembly drawing which shows all of the positions and part numbers, so that you can double check, because, of course, now the part numbers are covered up. The next thing to do is go ahead and put your sockets in. So we'll dump out the medium parts bag here. So I'll typically put one socket in and then hook the pin with your fingernail to make it stay, and flip the board over. And then again, just solder the corner pins for now. Go ahead and do your other 28 pin. And then grab the 16 pin off the piece of foam. And that goes in the position for the max 232. And again, just grab it with your fingernail to make it stay in the position there, and solder the corner pins. Alright, we're going to inspect again. Make sure everything's tight down to the board, and make sure pin 1's the right direction on the sockets. And now we're going to go ahead and solder the R65X1Q in. These, you can get sockets for them, but the sockets that we tried did more damage to the pins than I'd really like to see. On the outer pins, it would push them up, and then when you went to remove them, it would pull them down. And so we figured, what's the point in a socket if it doesn't protect the chip that it's supposed to protect? So we're advising everyone to just solder these in. They're a little finicky to line up because you got 64 legs in a staggered pattern there. Just be gentle and patient with it, and don't try to force it in or hurry with it. I know I'm probably out of shot here, so sorry for that. But yeah, little finicky to get in there, and it's way worse with a socket because the holes are smaller on the socket than the holes in the board here. So yeah, same as the others. Just make sure it's down tight. It's a little shorter than the other chips, so you might want to take something like resistor lead form or any old little thing, and just give it something to rest against there. And then again, just solder the corner pins. It doesn't matter which corners, just I typically do pin 1 and the one opposite. And again, just double check, make sure everything's in the right way. On the 6501s, the text should be the same direction as the other chips. You see it has a notch on both sides here, but there's also a tiny notch right here in the corner that's your actual pin 1 indicator. So that's how to tell on these guys. Alright, now with all that stuff tacked in and verified, we're going to flip it over, and we're going to just tear through the solder joints on the back of this. So with the quip packages, what I typically do is I'll go down one side, and then go down that one on the same end of the row, and then turn the board instead of trying to reach over the other row of pins there. It's a little bit of a pain to get to. So as you can see, your iron would have to be up like this, and yeah, it wouldn't be great. So let's go over and rip down through the other side here. And then I just rotate the board around to get to the other set of pins on there. Alrighty, so that's that one done, and then we can turn her back over and go through all the dips. And so the thing about soldering the corner pins is now I can start up here, I can go down, go over that pin if I need to, then cross over, come back up this side, and just sort of zigzag across there, which is a pretty efficient way to do it to make sure you don't miss any pins. By far the most common problem that we've had at actual in-person workshops are mist pins and cold solder joints. So make sure you get them all, and going through them in a pattern like that is one of the best ways to make sure you do in fact get every single pin. This board's not too bad to solder for beginners, but I mean it's medium complexity. There's a fair bit of stuff on here. It's not as bad as like the 8085 single board, but it's also not as simple as like the XTIDE kits. You don't want to put a ton of heat into the joint on the sockets. It doesn't matter as much with the chips, but the sockets are made of a thermoplastic, so they will actually reflow if you get them hot. I think chip bodies are typically epoxy, so you don't have to worry about that. So that's the top row done. We'll just move on to the bottom row now. More of the same. Alright, and again you want to go and check over everything and make sure you don't have any missed joints or any cold solder joints. If you're not familiar with soldering, or you don't have that much experience with it, the user manual links to the Adafruit guide to soldering. We don't really have our own soldering guide up, since plenty of people have that and they probably explained it better than we would. Alright, so that's all your IC sockets and ICs. The next shortest item is going to be your resistor pack. And the trick to the resistor pack is, first have all the legs straight. Sneak in under one of the pins here and solder it on the top, just to hold it in. And then you can look down from above and straighten it up. These do have a pin 1 on them. It's marked with a little dot. The dot needs to be toward the square area. And if you get that in backwards, it will cause problems, so don't do that. And just go ahead and flip it over and solder it. And go back and touch up pin 1, since it doesn't always flow nice down through the hole. Your next item is going to be your push button reset switch, and there's 2 orientations this can go in. Either one will work. It will not go in if you have it 90 degrees out. The spacing's different, so you don't have to worry about that. And those are snap fit, so they stay put. Oh, probably should have mentioned before we got into this. So this board is compatible with right angle versions of the push button switch and all of the external connectors. I brought one of our prototypes that was used for sizing a lot of the positions on that stuff. You can see here it's got a right angle switch. It's got right angle connectors for all of these, and that's sort of nice if you're using it down in a glitch bus backplane, or if you have it as the a middle or bottom board in a board stack, so that your cables are coming out to the sides instead of having to come up and over. And then you can also get to the reset button when it's in a board stack. So we don't provide those with the kit. If folks would like to see that as an option, just let us know, and we can add them as an optional thing to the kits listed on the Tendy store. But yeah, if you have your own right angle versions that you want, just go ahead and substitute those. Alright, and let's see. Probably our switch pack is going to be our next tallest thing. Switch packs do have a pin 1. It's marked with the little dot there on the corner, and switch position 1 should be up. So just flip that over and solder it down. I usually do the same as I do on the ICs. I solder the corners, and then I flip it over and make sure that I do in fact have it the right way up and that it's tight down to the board. I may not be following the exact order of what we put in the manual there, it's not super critical. It's not like you can't get the parts in if you do them out of order or something. But the general idea is just go from the shortest components up to the tallest, so that they keep themselves tight to the board when you flip it over, without having to use a support or a vise or anything like that. And we'll go ahead and do the yellow capacitors. These are 22 microfarad 16 volt, and those go around the max 232 right here. The negative stripe, which is the little black ribbon with, get you to focus here. There you go. The little arrow with the stripe there, that goes toward the solid portion of the little symbol on the silk screen there. So you want to install it with that negative stripe down, and that is the same for all of these. I've had some folks ask online why we use 22 microfarad when one will work, and it's mostly because we have about 10,000 of these capacitors in stock, so we use them on everything that uses a max 232. And using a larger capacitor, if you're being reasonable, is not a problem on these things. It also allows you to draw a few milliamps of plus and minus 10 volts off of these. So if you're designing something where you need plus and minus 10 volts for like an op amp or an ADC or a DAC or something, that's a convenient trick to pull it off of an otherwise 5 volt only board, is steal it off the max 232. And then we'll go ahead and do the axial capacitor here. This guy has a black stripe on it, and the black stripe has an arrow end. The arrow end points to the negative side. The negative side also has blue tape from where it came off the reel. So go ahead and pull the tape off like we did on the other capacitors, and then bend the leads down. You don't have to use a form. And then your plus side is marked on the board here, so just make sure that your plus end is the right way around, or the thing will cook itself when you put power to it. And if you do that, if you get the capacitor in backwards, it's ruined. Do not try to flip it around and reuse it. We've had a couple people at workshops do that and find out, yep, once you short it, that's it. It's done. And clip the leads off. And then we're going to go ahead and put in our little reset circuit here. This guy looks like a transistor, but he's not. This is actually a reset supervisor. It's a Dallas 1233. That goes in this little position here. Just bend the legs out so it'll go down in there and mash it down till it's about where you want it. And solder it in. And these, of course, do have a pin 1 to them. If you put them in backwards, they're dead. The solder mask has, silkscreen has the pattern that matches up to the correct orientation there. Alright, we'll go ahead and do our 10 nanofarad for that. These are the capacitors that we shipped with the hobbyist kits. It's the one that's not on the tape, and it'll have a 0.01 for the value on there. These are not polarized, so they can go in either way. And if you're getting a kit somewhere down the line, your capacitor may be a little different than that, just because we use what we have on hand, and it's not critical as to the manufacturer tolerance on it. This cap just gives you about a 500 millisecond delay when you hit the reset button and when power comes up. So it's a switch debounce and gives you a delay to give you a nice clean reset pulse. Alright, we're going to install the 22 picofarad capacitors for the crystal. If you look on those will have a 22 printed on them. They're the ones on the tape for this kit. Again, in the future they may be a slightly different configuration. Just snip those off of there. They don't tend to pull out cleanly from that tape, so we just cut them off. And again, no polarization, they can go in either way. I typically let those hang off of the desk when I solder them so that we'll have enough lead stick out to get solder on both sides. So otherwise, the little dip that they apply to these for the encapsulation will prevent you from soldering. And if it's really bad, you actually won't get solder sucked up into the through hole at all. So you can let them stand off the board just a little bit. Put the leads. Alright, looks good. We'll go ahead and do the connectors next. The crystal is the tallest item, so you should do that last. I tend to do the 10-pin connectors first. There's 2 of them. It doesn't matter which way around they go. They're not keyed or anything. Put them in, flip it over, and then put a little pressure on the board to actually get them square with the board. And again, turn it over and make sure you are actually down on the board. To get them in crooked, and you start soldering it, it's basically going to be stuck like that. If you don't have a vacuum desoldering station, you're going to end up having to cut it out and destroy the header anyway. So, best to get them right the first time. Alright, we'll go ahead and do the other 10-pin header. These headers connect to some of the internal I/O ports on the R65X1Q, so you can run a cable right off of there for interfacing to switches or LEDs or whatever. If it's not setting totally square in there, just put your finger against the pins you're not soldering. So we're going to solder over on this end. Our fingers are touching the pins over there. Don't do the ones that you're about to solder or you will get burned. And just heat it up and let it drop square to the board there. We had been doing press fit holes for these, but I'm not sure if it's manufacturer variability in the headers or if it's variability at the circuit board house we use, but sometimes they're so tight you just about can't get them in. We do press fit the Molex headers, so you want to make sure these are going the right way. You'll see up here there's a line off to one side. That's the end that the tab should be on, so you want to have it with the tab toward that double line. And they are press fit, so you have to sort of wiggle them just a little bit to get them to drop in there. That's intentional. It's supposed to grab that and hold it so that the part doesn't fall out when you turn the board upside down. And same with the 5-pin for the serial connector up here. You want the tab to match the double line on the circuit board. And again, if you're doing right angle, you substitute your own parts here, and don't put the straight through ones in because they're hard to get out. And just go ahead and solder those down. Now the power and serial connections on this are the same as they are on the 8085 single board that we did a couple years ago. So if you have pigtails made up for that, you can just use those when you go to test it. Alright, and we'll put the 4 megahertz crystal in, and that goes over here. And again, no polarity, so put it in either way. That's the tallest guy, so that should hold itself up when you flip the board over. Alright, and that's basically it. So now if you're going to wash the board, whether you've used water-soluble flux or whether you're using rosin flux and alcohol, I do that before we put the chips in. So this board, I don't know how well that comes across on the camera there, but it's got a fair bit of goop on there from that water wash flux. So this is going to get washed in hot water and then go into our hot air drying cabinet, and then we'll stuff the ICs into the sockets. But that takes like 45 minutes, so we're obviously not going to do that on this live stream. Instead, I have another one already built up and washed. You can see here it's already got the chips stuffed into the sockets, and we'll go ahead and fire this thing up. The manual contains instructions on how to put together your serial pigtail and of course your power pigtail just needs the end stripped and hooked up to a 5-volt supply. We recommend using a supply that can do at least 500 milliamps if you don't have any glitch bus boards or anything hooked to it. More boards means you're going to need more power. We already have a set of cables made up, so we're just going to use those. The pigtail here goes over to our VT320 terminal. We already have all that set up. Set these chips off to the side here. So your serial cable plugs in on top, and then your power cable plugs in to the other molex. Now this does have a reset supervisor on it, so if your power supply is too far out of spec, the thing won't come up, so you need to actually check with a meter or something and make sure you're getting 5 volts plus or minus 5%. Alright, you want to swing the camera around to look at the...
Let me move the laptop pieces over.
Oh, okay, yeah, that's fine. We're going to reposition here. It'll be just a second. Alrighty, we got the VT320 fired up here. So with the single board, you're going to want to make sure that all of the option switches on SW2 are off for testing, and that's going to give you a 4800 baud serial console if you're running with the R6501Q with the 4 megahertz crystal. If you're running with a different crystal or want a different bit rate, just check the manual. We have all that documented in there. So just go ahead and apply power, and it should automatically reset when the power supply comes up, and you'll be greeted with the sign-on message, EWAS 1.1 for Glitchworks R65X1Q SBC. We have our code for the extended WAS monitor port to this up on GitHub, which includes some sample use instructions and a link to a site with more detailed instructions. But we'll just examine a block of memory here. And yeah, so you can see we're running fine. So that's basically it for check out and test on this. The manual includes some troubleshooting instructions. But by and far, the biggest problem that we've had with these at workshops are missed solder joints and cold solder joints. Occasionally you'll have solder bridges, but being a mask board, it's not that big of an issue. All right. Does anybody have any questions for us? Is anybody following along at home and building their board right now? No? Oh, okay. One person building on. That's I didn't know how many people would be up this early. Figured a lot of this would be getting watched later in the afternoon. Yeah, we got a little more experience building these. I mean, we made 5 prototypes, and we've sold several assembled ones. So don't feel bad. We've built a bunch. Okay, yeah, you like the build stream? Yeah, we typically do an in-person workshop. I don't know if you've been to VCF East in recent years, but of course with the pandemic, we're not doing anything in person this year. Oh, and for power consumption, let me flip it over to amps here. We're setting right at about 250 milliamps. So if your board is drawing substantially more than that, you probably have an issue. And if you're building at home and you're using different series of parts, you may have a little more current draw than that. But if you're seeing 400, 500 milliamps or more, you probably have something wrong with your board. The biggest thing I'd look at is backwards electrolytic capacitors or a backwards chip. Oh, okay. Yeah. Yeah, the 8085 is a little more involved, but again, not a terrible board to build up. It'd probably take an hour or two for you. All right. Well, I guess we'll wrap it up here then, and we'll move it on over to Discord and IRC. Thanks for watching, everybody, and if you like it and want more of it, let us know. Otherwise, it'll be just one of those things we do when there's a pandemic. Thanks, and have a good day.